Good morning, everyone. Joshna, Chintu, Rutvika, Jameer. Am I audible? New lesson, yes. So we will study today hydrogen chapter because we have already completed periodic table. Your test was yesterday or is it today? Yesterday only, okay. How was the test? You were able to solve questions? Call your friends quickly. We'll see everything. So you were able to solve the questions of periodic table yesterday in the test or not? Okay, fine. Chalo, very good. Jyoti, Durga Prasad, Syam. Okay, so now see what we have to do. Okay, acha, I also told you to find a list of amphoteric oxides from P block, group 13, 14, 15. We will write it at that time also. Now we have written only the special ones. Okay? And we have written about the anhydride and all. Okay? Chalo, theek hai, fine. So the next chapter which we have to see is your hydrogen. Which chapter is there? We are having hydrogen chapter. ठीक है ना? Now we can see कि everything in hydrogen is theoretical only. ठीक है ना? You also know the point. ठीक है ना? We have to write only and we have to discuss. And anyhow we have to learn it. ठीक है ना? Anyhow we have to learn it. Clear? Okay. So everyone take out NCERT also. Keep it near you. Take out NCERT and keep it near you so that you can revise once NCERT now only during the class. So everyone take out NCERT of hydrogen chapter. ठीक है? ठीक है? Clear with all the points? Okay. So what you have to do, we will also write from NCERT only. We are strictly following NCERT, and you can also read it from there. Whatever points, if you like, you can tell from there also. ठीक है ना? And so that you are able to see whatever is written in NCERT now only. ठीक है ना? Once you will see it now. ठीक है? We will see few explanations also. See what happens na, generally if we discuss something then it remains in our memory for a longer time. ठीक है ना? So we can learn it for a longer time. So this is the target of all these classes. Because whatever is written in NCERT, we also discuss the same points. ठीक है ना? At least we highlight the important points. If you read our notes also, then we can say that almost everything of NCERT we have written. So you don't need to read NCERT line by line. So you save some time also. Okay? Clear with this point? Okay. So let's start with this. So NCERT hydrogen chapter. Now, second book. So what we will see that hydrogen is the first element having atomic number 1. But its position is still not clear in the periodic table. Okay, na? Position in periodic table is uncertain. Periodic table is uncertain. Why uncertain? Batao. Because it resembles which groups? And see, to make this session interactive, you will have to reply also. Okay, na? So basic things are there only. So if you know something, you reply. Because it resembles group 1 and group 17. Few properties are similar to group 1. ठीक है ना, few properties are similar to group 1, similarity with group 1, and it also has some similarity with group, कौन सा group बताओ, 17. So whatever you are knowing, you just write in the comment section. I will also check it once. Similarity with group 17, and target is to learn everything in the class only. ठीक है ना, target is to learn everything in the class. Whatever we will study now, all things you should remember within the class only. We are not going to leave anything for evening study hours and all. ठीक है ना, so we'll learn it here only. Group 17 means we are talking about halogens. Okay, so first of all we will talk about some points which are similar to group 1. Do you know the points? First point is your NS1 configuration. First point is your NS1 configuration. Second point, you can say कि we like lithium, sodium, hydrogen also forms H plus. So this is the second similarity, you can say. Clear? So it is also forming a cation. At the same time, if you will see similarity with group 17, you can say कि it gains 1 electron. It gains how many electron? बताओ, 1 electron to attain noble gas configuration. To attain noble gas configuration. ठीक है, like halogen F minus Cl minus, so it is also present like Cl minus F minus. We also know कि hydride is there which is present as H minus, which is having the configuration of helium, which is having the configuration of helium. Very good. So everyone is knowing these basic points. ठीक है, अच्छा, one more similarity is with group 17. You know कि all are present as diatomic form. Fluorine, chlorine, bromine, hydrogen is also present as a diatomic molecule. ठीक है, clear with this point? Anyone can teach, all are same only, they teach similar things, and for NEET we follow NCERT, so it doesn't matter much. Is it clear? देख लो. So fluorine, chlorine and hydrogen. Okay, ठीक है, fine. Now these are basic things. Now we will write one important thing which is slightly of higher level. What is that important thing? This is related to reduction. This is related to reduction. Do you remember electrolysis? Do you remember cathode? Can you tell what happens at cathode? Oxidation happens or reduction happens? Cathode is negative terminal or positive terminal? Can you tell? ठीक है, reductions happen, so this only you have to reply. Very good, Vijay. So cathode is negative, and always reduction happens on cathode. As it is negative, it will attract the cation H plus will take 1 electron to give half mole of H2. Same thing you can write like this कि half mole of H2. You can multiply 2H plus 2 electron will give rise to H2. So these reactions happen at cathode. Whereas in the other part, sodium also, suppose you want to get sodium, you will do the same thing. Sodium is also a cation, it will take 1 electron and it will become sodium like this. So like alkali metal, it is obtained at cathode by reduction. Okay, like alkaline earth metal, do you know what is the sign of anode? Positive. What happens at anode? Always oxidation happens at anode. So what you will find ki hydride ion H minus will lose 1 electron and it will be converted into H2. Similar thing will happen with chlorine also. Cl minus will give half Cl2 plus 1 electron. So properties are similar to, ठीक है ना, properties are similar to group 1 also and group 17 also. Is this point clear? So I think only one point was a bit new type, that is your this point. ठीक है ना, so we will see this in future also. So keep this in mind, H plus is there and H minus is there. H minus, if you take, oxidation will happen at anode and you will get hydrogen gas. If you take H plus, reduction will happen at cathode and you will get hydrogen gas. Is it clear? So done, ho gaya. Simple basic things, nothing very much difficult. Acha, now what they are saying ki it's ionization energy. Ionization energy, there is one similarity with group 17 and one unsimilarity also. What is the similarity, you know? Do you know the ionization energy of hydrogen? Do you know the ionization energy of hydrogen? Okay. So what do you think? It will resemble group 1 or group 17? But before answering this, you should tell ki what is the ionization energy of group 1 element? Is it low or high? If I ask you like this, ki ionization energy of alkali metal is high, true or false? Ionization energy of alkali metal is high, true or false? False. Ionization energy of alkali metal is least in its period. And halogen, it is very high, because you cannot remove, it is very difficult to remove electron from halogen. So what you will see now, ki ionization energy of lithium is 520 kilojoule per mole. Ionization energy of lithium is 520 kilojoule per mole. Fluorine is 1680 kilojoule per mole. And what? If you check for hydrogen, it is similar to fluorine. It is your 1312 kilojoule per mole. So it is resembling halogens. It is resembling halogens. So is this point clear? Done? Okay. So today you can find also less important things are there, very easy things are there, but I am telling you again, we will highlight those points which you may generally forget and you may think this is not important, leave it. But the questions are asked from this point also. Do you know the questions have been asked from simple this point also, ki what are the isotopes of hydrogen? 3 things were written. Hydrogen, that is your protium, deuterium and tritium. This is also one of the previous year question only. So clear with this point? Okay. Now what? But there is one unsimilarity. Can you tell me one similarity which not matches with this also and that also? One similarity. This is all about it. Can you tell me one similarity which is different from both? Means alkali also not matching and a halogen also not matching. What we can say? Alkali also not matching and halogen also not matching. This property is totally different from alkali also and halogens also. What we can say? Reactivity. Reactivity. We know ki alkali metals are highly reactive. We know that halogens are also highly reactive. But hydrogen is inert at room temperature. Inert at room temperature. ठीक है ना? But halogens are highly reactive. But halogens are highly reactive. So this point is different. ठीक है ना? So main 2 points you can keep in mind. I am highlighting this because you will forget it. One point is this and one point is this. Now later on we will also see what is the reason behind it. What is the reason behind? Can you tell why hydrogen is very less reactive? Why hydrogen is very less reactive? We will write it after this also, but can you tell this point? Why hydrogen is very less reactive? Let's come to the next topic, that is your occurrence. Small size. Bond energy is very high. You remember chemical bonding, when we draw that graph of VBT, we take hydrogen as the example. Very Thanmay correct, saying correct. More bond energy, 436 kilojoule per mole. So we will write all these points. And we will write the data also, ki at what temperature how much dissociation is going on. You will be surprised to know at 2000 Kelvin very less dissociation. 5000 Kelvin, 5000 Kelvin required for dissociation. Are you getting this point? So all these things we will discuss. You also try to reply. Target is to learn everything in the class itself. We will not leave anything for the future. Clear? So now let's talk about occurrence. What happens then? Generally everywhere we talk this is the most abundant element in the earth crust. Who is the most abundant element in the earth crust? Do you know this point? Who is the most abundant element in the earth crust? We remember at least 2-3, you know. Which is the most abundant, second most abundant, third most abundant, fourth most abundant element in earth crust. So generally we talk about earth, but when it comes to hydrogen, we talk about universe. So when you will see the occurrence of hydrogen, it is maximum in the universe. Universe means what? Everything, earth and other things also. So universe. Then it is present on sun. They say that in sun hydrogen is present at atom. Then fusion reaction takes place, hydrogen helium, which is highly exothermic. And then you can say it is present on earth. It is most abundant in universe. Most abundant in universe. Clear? So we will talk all these points. In earth crust you can say it is around 9th present in the earth crust. Clear? Done? Achha, do you know about the isotopes of hydrogen? This is also a previous year question. I am telling you, isotopes of hydrogen. Which isotopes you know? 1 that is your protium. That is your protium. Every point of NCERT is important. They are asking questions from everywhere. Deuterium and tritium. Which one? This is first question is this. Previous year question. Listen to me. First previous year question was this. Which are the isotopes of hydrogen? So simple. Everyone will tell, sir. Very easy. Protium, deuterium, tritium. Done. Then the second question was, out of this, which one is radioactive? So the answer was tritium. Tritium is radioactive. Then they asked this also. What is the T-half? What is the T-half? Do you remember? Bolo. Tell quickly. 12.33 years. Then this is also a question. Which rays or which energy particles are liberated by tritium? Which energy particles are liberated by tritium? Do you know this point? Tell quickly. Which particles are liberated by tritium? Beta particles, low energy, high energy. Low energy, high energy. Emits low energy. So all these are question. Beta particles. So all these are PYQ. So you can see all the lines question can be generated, and if we discuss these things, then only we can learn it. So if you know the answer, write quickly. This. So there are few chapters. All the chapters in track 3 are like this only, where you will tell something. That's why I told you to open NCERT. No problem. You tell something, I tell something. We will discuss. We will learn. Clear with this point? Okay. Then they ask you second point. Who is most prominent out of these three isotopes? Who is most prominent? Who is mostly present? Hydrogen is mainly present in form of protium. Least present in form of tritium. Then about deuterium, they say कि only protium is most present, tritium is least present. Tritium is least present. Then they give 1 point written in NCERT. How much deuterium is present on earth? Can you tell? How much deuterium is present on earth and in which form? Which form is also important. You will think, kya sir, deuterium to D2, so it is present in form of D2. Wrong. Read NCERT, read NCERT, they will write there. They will write the point there ki terrestrial hydrogen contains how much percent? 0.0156% of deuterium. Only this much deuterium is there. In form of what? HD, high definition. It is not, HD is not a high definition. It is hydrogen and deuterium. This form it is present. Clear? So all these points are very important. So you have to keep all these things in mind, especially the data of tritium. So hope everything is clear till this point. Low energy beta particles, and we are saying ki T half also we remember, deuterium is present in form of HD. So is it clear? Nah, done? Okay. Now come to the next point. They talk about physical properties. Physical and atomic properties. Now you will find a table in NCERT. Can you see the table? Okay. What we have to see from that table? They ask question from that table also. See, you will attend hydrogen chapter class here, means NEET syllabus done. They will not ask anything outside it. So when you will see the properties table, they have written hydrogen, deuterium, tritium. Clear? Tritium radioactive, very less present. So most of the data we don't know also, and we are not interested also. Clear? So in tritium, most of the data are not written. Means we are mainly interested in protium and deuterium. We are mainly interested in protium and deuterium. Clear with this point? So when you will see the data, you will find that abundance only hydrogen is more, 99% around. In rest of the properties, when you will check the properties, check once: melting point, boiling point, delta H vaporization, check, delta H fusion. All these properties, whatever density, so whatever physical properties, we will say bond energy, atomic and physical properties. What you will see ki deuterium is more than hydrogen. All these cases, because deuterium mass is more, you can say tritium, correct? You can say like this also ki TDH. Although less data is known for this, less known. So we are not interested in tritium. But due to this mass and bond energy thing, the data of D2 is more than protium. But one data is same. Can you check this data? One data is same. Which data is it? Quickly. Which data is there which is same? Can you see? Internuclear distance. Internuclear distance means what? Bond length, or you can say radius part. Internuclear distance. Internuclear distance only you were doing divided by 2, you were getting radius. This is same for D2 and H2, and that is equals to 74.14. It is written in picometer there. Clear? So we have written in radius chapter also. Radius chapter also we have written ki bhai radius is same. In fact, ionization energy also you can say ki 2 points I am telling you, listen carefully. Radius of isotopes same. Ionization energy of isotopes also you can take same. Done? Rest all the properties of D2 is more than H2. You can see now if anything is different you can tell, but you will not find anything different. Fine. So till this point we have done everything. Now finally what we have to see next? Next we have to see ki how isotopes differ. They will say like this: for isotopes, what they will say, you know, ki chemical properties same. Chemical properties are what? Same or different? Batao. Chemical properties are almost same or different? Same. Because chemical properties depends on, as it depends on what? Batao. As it depends on valence shell configuration, which is same for all. Clear or not? Hydrogen also 1s1, deuterium also 1s1, tritium also 1s1. So chemical properties are same, but two things are different. Two things are different. ROR. What is this ROR? One student wrote there ROR. कहाँ गया? कौन लिखा था? जमीर डिलीट मार दिया क्या? So ROR is what? Rate of reaction. ROR is what? Rate of reaction. Rate of reaction is different. ठीक है ना? With deuterium rate of reaction is generally less than hydrogen. Deuterium reactions are slow. Same reaction will happen, but the reactions are slow. Deuterium reactions are slow. Why you can say slow? Because bond energy is more. Bond energy is more. It will take time to break the bond. It will require more energy to break the bond. So the reaction is comparatively slower. ठीक है? What is the other point you can say? Physical properties, which are, you know, na, melting point, boiling point, dependent on van der Waals forces. Van der Waals force is directly proportional to molar mass. Who is having more molar mass? D2. So you can say physical properties. We have seen before also physical properties. What you will say? D2 is more than H2. Why? Molar mass is more. So are all these points clear? Ki chemical property is same, but physical properties are different. Done till this point? Are you clear with all these points? Okay? So all these points are important. Ki chemical property, they will ask you like this, ki which of the following properties are similar for isotopes? What is your answer? All the chemical properties you can say. Which of the following? Why a reaction with deuterium is slower as compared to hydrogen? What you will give the reason? Why reaction of deuterium is slower with respect to as compared to hydrogen? What you will say? You will simply say that bond energy of D2 is more. Correct? You can write in shortcut also. Okay, Vijay, Blessy, okay, Navid, Surya, all of you can write short. B, we understand. Okay, na? Okay, and everyone who is interested in learning these things, I am telling you, confirm. Okay, na? Check the question which came from hydrogen in this year also. Okay, na? You can clearly get whatever is written in NCERT, and our target is to learn NCERT. Okay, na? Within the class itself. We are not going to leave anything for future. Means later on study hours you study physics and bio. Okay, na? Track 3 chemistry we will complete in class itself. Everyone will remember. But one condition is there. You can remember these things in class only if you reply. Only if you reply. Gaming. Storm gaming. Okay. Chalo, theek hai, fine. So done with this one? Clear? Okay. Now they will talk about preparation. Ki how we are doing preparation. कैसे करेगा preparation? So they have given some lab methods. We are writing according to NCERT. Ki lab method is given in NCERT. Ki if you take like zinc, you react with HCl. ठीक है ना? This reaction we studied in the last class also. Oxides. Do you remember? Ki metals can react with water, oxides can react with HCl and NaOH. Then we wrote the reaction ZNO, NaOH. ठीक है ना, ZNO is amphoteric, ठीक है ना. So let's write this one first. कि first point we are writing कि reaction with water. Reaction with water. So what happens now? Depending upon the reactivity, now this comes in electrochemistry chapter. You will find electrochemical series. Some metals are more reactive, some metals are less reactive. So what will happen? These metal will react with water. ठीक है ना? Like I will give you example. Like suppose you are having suppose lithium only. ठीक है ना? Lithium, sodium. So they will react with water. ठीक है ना? What they will form? बताओ. If lithium, sodium, potassium they react with water, what you will form? You will form hydroxide, and what you will get? कि hydrogen gas is liberated. Hydrogen gas is liberated. Few elements will be there कि where it does not react with cold water, it reacts with warm water. I'm giving you the example here. Here the metals can be high reactive metals. High reactive metals like what? Lithium, potassium, calcium, sodium, like these. These are high reactivity metals. Reactivity is high, so they can react with cold water also. Now suppose less reactive metals are there, which can be after this. Batao. Like magnesium, aluminium, zinc, they will not react with cold water, so they require hot water. So they will react like this, and they may form AlOH whole thrice, and what again will happen? Hydrogen gas is liberated. Clear? Then there are few metals who are lesser reactive than this. Like iron, tin, lead, least reactive metals. ठीक है ना? So they require not warm water also, they require steam. With steam, they will liberate hydrogen gas. So you can say one more point from here. What you can say, you know? You can say like this कि as reactivity of, fill in the blanks here, as reactivity of metal decreases, more temperature is required. That implies more temperature of water is required. Got the point? If highly reactive metals are there, like lithium, potassium, calcium, achha, these are border also. Somewhere you can find calcium written in the other section also. ठीक है ना? So we'll remember like this कि लेके कार ना मांगू आलू पानी जनता फेंकेगी टिन lead. Like this we have remembered something. ठीक है ना? So what happens if you take more reactive metal, अरे cold water also I will react. ठीक है ना? Like suppose some students are very much motivated towards NEET. What they will say? Arey sir, no problem. You take the class at any time, morning, evening, afternoon, night. Any time you take the class, I will attend it. ठीक है? Then few people are there कि ठीक है, they are also motivated and all. They will say, sir, night a bit problem and morning also a bit problem because I wake up late. ठीक है ना? Then you take class only in afternoon. Some more lazy people, they will say, sir, evening also you don't take, morning also you don't take. So these are the things changing. So if you are highly reactive, you will react with cold water. If you are medium moderate, you will react with warm water. And if you are very less reactive, you will react with steam. Clear? Okay. ठीक है. अच्छा. अब क्या है बताओ? So now these all things are based on electrochemical series. You will get a clear idea of this once you read electrochemical series also, because this thing is based on electrochemical series. Second point we can say like कि reaction with acid. Reaction with acid, dilute mineral acid, like this they will say. ठीक है ना कि dilute mineral acid, ठीक है ना, like dilute HCl, dilute H2SO4, like this we are talking about. ठीक है, so I am writing here one thing. You remember electrochemical series, H plus is there, copper 2 plus, Ag is down, and rest of the elements like lithium, these are up. So what is the logic? You know what is the logic? Logic is this, कि those who are more reactive than H plus, or those who are above H plus, can liberate hydrogen. Those who are below H plus cannot liberate hydrogen. So if I write here, suppose I am writing here sodium, and I will write here dilute HCl, then I can say कि I will get NaCl and hydrogen gas is liberated. But if I take copper, keep this in mind, if I take copper and I take dilute HCl, and if you are thinking कि I will get hydrogen gas liberated, ठीक है ना, then you are thinking wrong. This point is more important. Clear? Does not liberate. So they will ask you कि which of the following does not liberate hydrogen gas with dilute HCl, dilute H2SO4. Clear? So those who are below H plus, like mainly they ask the question from copper only. ठीक है ना? So copper, Ag, Au, ठीक है ना? You can take Au part also. ठीक है ना? So this is there. And this, where you will learn this thing? In electrochemical series. Happa. Correct, no problem. No, platinum, palladium, you are saying these things. ठीक है ना? Cu Happa. Cu, Durga Prasad is saying Cu Happa. So Cu is this, ठीक है ना? And then you can say like this कि Ag and Au, and then you can say palladium, platinum. We know palladium, platinum, noble metals also. So like this. ठीक है? Now what is happening? If we take some amphoteric metals, you know amphoteric metals, ठीक है ना? Amphoteric metals, like they have given in NCERT. Now here, this part we are writing in detail. In NCERT only one reaction is given, but here we are writing in detail. Like amphoteric metals can react with acid as well as base. So they have given in NCERT. Check NCERT once. They have given in NCERT you react with acid or you react with base. In both the cases, like you can write here, these are redox reaction type, you can say. ठीक है ना? So they will write here you can get Zn2 plus and H2 gas is liberated. ठीक है ना? Half H2, this is for balancing, you can write H2 also. ठीक है ना? In place of H plus you can complete it like this. How you can complete? See, in NCERT ionic equation is given. You can write Zn plus HCl will give rise to ZnCl2 and hydrogen gas is liberated. Zinc can also react with alkali like NaOH and it will form sodium zincate. This only we wrote yesterday also. Balancing you can do on your own. Similar things will happen with aluminium. Can you write with aluminium? All these are dilute acids and base. HCl, you will get AlCl3 and hydrogen gas is liberated. You can also react with NaOH and you will get NaAlO2 plus hydrogen gas. What is the name? Sodium aluminate. We wrote na? Sodium aluminate. This we wrote yesterday also. ठीक है ना? Other amphoteric metals were beryllium. Do you remember beryllium reaction? ठीक है ना? So beryllium also you can remember. Clear? Berylate will be formed. ठीक है ना? Berylate will be formed. I am writing, or you can write this much only. That is sufficient. Achha, they will say कि granulated zinc is there and all. Powdered reactions. They will use many things like powdered metal I am using, granulated metal I am using. So this is just to increase the surface area. This is just to increase the surface area so the reactivity is high. Now there is one thing. Listen this point. Listen this point very clearly, very carefully. Here you will be trapped. They will give like this, ki zinc is there, Babu, zinc is there, and I am reacting zinc with dilute H2SO4. And I am reacting zinc with concentrated H2SO4. Then what you will say? What is going to happen? What do you think? In which case in which case hydrogen gas will be liberated? बताओ, in which case hydrogen gas will be liberated? What you can say? बताओ, try to guess. ठीक है, we said in the beginning we are using dilute acids na. See, with concentrated, so here I will get ZnSO4, here I will get simple ki ZnSO4 is there and hydrogen gas is liberated, correct. But with concentrated what will happen ki concentrated H2SO4, two merits are there ki one thing is that ki it acts as dehydrating agent, and one thing you can also say ki it acts as oxidizing agent. So what may happen, it oxidizes zinc to Zn2 plus and itself get reduced to SO2 and you can say H2O. So you can see here ki sulfur is present in +4, here sulfur is present in +6. So this is one of the difference. ठीक है, if we say like this ki copper plus dilute H2SO4, we will say ki no reaction because hydrogen gas is not liberated. But if they say copper plus concentrated H2SO4, then you'll have to say ki I will get copper sulfate plus you can say SO2 plus you can say H2O. Clear? But these things, this much things are not in NCERT. I'm again telling you, only one reaction is in NCERT, but we are seeing here this part in detail. Only this part we will study in detail. ठीक है ना? Otherwise, no. ठीक है? So that's all. Don't worry. ठीक है ना? We are done with this part. ठीक है ना? Now directly come to commercial preparation. Commercial preparation means what? Large scale industrial preparation. How you will do large scale industrial preparation? First point, what is given in NCERT? This we are studying from childhood. Now, what is there? Dilute electrolysis of water. ठीक है ना, slightly acidic, H plus OH minus is added, then what you do, this is your water, you do electrolysis, you get hydrogen and you get oxygen. What you see there, hydrogen is twice that of oxygen. Hydrogen is produced at cathode, oxygen is produced at anode. And what is the relation between the amount? Acidification done, acidification, ठीक है ना, after acidification you can say. So what we are saying, बताओ कि what is the relation between the hydrogen gas liberated amount? So you will say कि hydrogen gas liberated is twice in moles and volume. Moles also you can say कि 1 mole of oxygen, 2 moles of hydrogen, like this. You can relate the same thing with volume also. 1 mole means how many liter at STP? You will say 22.4 liter. Here 44.8 liter. Clear with this point? So this is written in NCERT. Then second point is there, very important. They are saying कि I require pure hydrogen. Pure hydrogen. How you can get pure hydrogen? बताओ. More than 90. Pure hydrogen more than 99.5% purity. How I will get this? How I will get this? बताओ. So they will say here कि electrolysis of aqueous barium hydroxide. Acha, electrodes are also important, but I'm not writing so much about electrodes now because you will not understand. Importance of electrodes you will understand after studying electrochemistry. So here they are saying that we have taken nickel electrodes, and here they will say that platinum electrodes. Platinum is inert, it does not react. ठीक है? Barium hydroxide. So all of you know these things. So they will ask you this point. This point is very important now. They will ask you ki how I will get pure hydrogen. Is this clear? Done? So you will have to tell this. Then they will say, now this reaction is present in multiple places. You remember electrolysis of brine as a byproduct, in production of NaOH and Cl2. NaOH and Cl2 can be produced by electrolysis of brine. Okay, brine is what? Concentrated solution of NaCl. So this is present in S block also. This is present in metallurgy chapter also, many places. So they will write here two reactions. What reaction they will write? They will write anode reaction. Listen carefully. By electrolysis of brine. Okay. So what will happen? They will write anode reaction. At anode what happens? Always oxidation. So Cl minus is oxidized to Cl2. And at cathode what happens? We know always reduction. Here water is reduced. Water is reduced to give H2 and OH minus. देख लो एक बार. Okay. You can write like this also, the equation. Balance. If you are interested in balancing, you can balance like this. So what will happen, you know, कि hydrogen gas is liberated at cathode. This only we wrote in the beginning. And can you guess what will be the nature of solution? Nature of solution will be basic. Na plus will combine with OH minus and it will form NaOH. Okay? So they ask all these things. Clear? Dekh lo. That's it. So they will ask you high purity. They will also ask you nature of solution. Okay? What is the next reaction? Do you remember? This reaction which we are going to write next, it comes in, where it comes? It comes in carbon family. It comes in carbon family. It comes in organic chemistry also. What they will say, you know, fourth point, they will say ki treating what? Treating hydrocarbon and coke, or you can say anything you can use, or coke with steam in presence of catalyst. Now this reaction is very important, presence of catalyst, because few things are formed here and we will extend it also. Okay, na? Like they have written a general equation in NCERT. I will take a regular reaction, like suppose you have methane and you are taking steam, H2O gas, in presence of nickel as the catalyst, then you will get CO plus H2. Hydrogen gas is liberated. What is CO plus H2 collectively known as? Do you know? What is CO plus H2 collectively known as? जल्दी बताओ. CO plus H2 को collectively क्या बोलते हैं? This is known as water gas. Then the question arises, what is the other name for water gas? Water gas is also called what? Water gas is also called syngas.